Hey guys! So today we're going to talk about factoring by the greatest common factor. So first we got to talk about what is a factor. Well, a factor is any polynomial that divides evenly into a larger polynomial. So a factor is any polynomial, and remember a polynomial can be 6 or 7x squared or 7x to the 12th power, anything that has an exponent that's not a negative or a fraction or a decimal. So a factor is any polynomial that divides evenly into a larger polynomial. That basically means all of the factors of a polynomial can be multiplied back out to get that larger polynomial. So if we look over here, what are the factors of the product? So this product means lots of things are multiplying to make this large thing here. So we're just going to break it apart. What things are multiplying? Well, right here I have 6 times x squared. So I'm going to write 6 times x squared times y. And these things are touching, so it's also times x minus 2 times 2x minus 5. All of those things are touching, so all of those things are multiplying. But we can actually break this down a little further, because what is x squared actually? Well, x squared actually is 6 times x times x. So I broke this down into its factors, which are x and x, and everything else is just fine. So we'll leave just times y times x minus 2 times 2x minus 5. So all of these things are factors of this larger product over here. So today we're going to learn how to take large things, large polynomials, and break them down into all of their parts. Okay, so we're going to go ahead and we're going to find the greatest common factor of these two numbers here. So we'll start with numbers first. So we're going to go ahead and do it two ways. We're going to do it with method 1. Well, method 1 says do the prime factorization of each term. So this term here is 36. So the prime factorization means I want to break this down into all of its factors, every single thing. So pick any two numbers that you know multiply to be 36. Well, I know that 6 times 6 is 36. You may have done 2 and 18 or whatever else you wanted to, but I did 6 times 6. Well, I want to go to the prime factorization, meaning I want it to be all the way down to prime numbers. Well, 6 is not prime because 6 is 2 times 3. Well, 2 can't break down any further because 2 is just 1 times 2. 3 can't break down any further either. So I like to circle the ends of my little branches so I know that they're stuck. Well, this 6 is also a 2 times 3, so I'm going to go ahead and break him down to a 2 times a 3. 2 and 3 are both prime. So these are all the factors. If you type in your calculator 2 times 3 times 2 times 3, you're going to get 36. So those are all the factors. So that means that 36 in all its factors is 2. I'm just going to write them in order so it's a little cleaner. So 2 times 2 times 3 times 3. So those are all the factors. All right, let's do the exact same thing with 54. You can pick any two numbers you want to, but it's an even number and I don't know what it is exactly, so I'm just going to divide by 2. If I need to do it with my calculator, I can. But 54 divided by 2 is 27. Well, 2 can't break down any further, so I'm going to stop that guy there. 27 I know is going to be 3 times 9. Okay, well 3 can't go down any further, so I'm going to circle that factor. But 9 I know is the product of 3 times 3. And 3 again is stuck. You're looking for 2s and 3s and 5s and things like that to be at the end of your branches. Okay, so that means that 54, its factors are 2 times 3 times 3 times 3. If I multiply 2 times 3 times 3 times 3, I'm going to get 54 back. These are all its factors. All right, so the next step is I want to go find the shared prime factors. So I'm going to write myself a little thing here for shared. So who do these guys share? We'll just look through your list. They both share a 2. There's a 2 here, but there's not a 2 here. So I'm going to, oh, they both share a 3. And they share another 3. So the shared factors are 2 and 3 and 3. So the GCF, the greatest common factor for these two terms, is 2 times 3 times 3. Well, 2 times 3 is 6, times 3 more is 18. So the GCF for this answer is 18. Okay, let's do the same thing again, but let's throw in some variables. So we're going to try to find the GCF for 8x squared y and 24x cubed y. All right, I want to go ahead and break everything down into its factors. Well, 8 broken down is 2 times 4. Well, 2 is prime. And 4 I can break down further to be 2 times 2. Those guys both are stuck. 2 times 2 times 2 is 8. All right, let's look at the 24. Pick any two factors of 24 that you know multiply. You can do anything you want to. I'm going to go ahead and do 6 and 4. Well, I know 6 can go further. 6 is 2 times 3, so he's stuck. But 4 is not stuck. I didn't circle that branch. I've still got more to go on that guy. 4 is actually going to be 2 times 2. So I can take those guys down a little further. All right. So we've done our prime factorization for the numbers. So we have all those numbers there. Let's go ahead and actually write out what these guys are. So we have 8x squared y. Well, 8 comes from 2 times 2 times 2. 2 times 2 times 2. Well, what does x squared actually mean? We talked about it above. Well, x squared means I'm timesing by x, and I'm timesing by x. I'm doing x twice. And there's just one y hanging out there at the end. So this is, if I multiply all these things together, I get back my 8x squared y. Let's do the same thing for 24x cubed y. Well, 24 we just broke down was 2 times 3 times 2 times 2. I'm just going to write it in order, put all the 2's first, and then put the 3, but it's still the same. And then x cubed really means I'm multiplying x by itself 3 times. And there's one y hanging out there, so he's just times y. All right, well, I need to find the shared prime factors. So I'm going to go over here and I'm going to say shared. What did these guys have in common? Well, I'm going to go look through. Well, they both have a 2, so I'm going to circle. And it really helps if you circle them. That way you don't accidentally double count them. Oh, here's another set of 2's. Oh, here's another set of 2's. This 3 is hanging out by himself. He doesn't have any partners. But here's an x and an x. Here's another set of x's. This x is hanging out by himself, but they both share a y. And it might be helpful if you write these down as you circle them, but I can just go back and look. 2 times 2 times 2. So they share a set of 2's, another set of 2's, another set of 2's. They don't share 3's, and they share one set of x's, oh, 2 sets of x's, and 1 set of y's. So I have 1, 2, 3, 4, 5, 6 things circled. I have 1, 2, 3, 4, 5, 6 factors, so I know that I've got everything accounted for. So then my GCF, my greatest common factor, multiply the factors together. 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. X times x is x squared, times y is just y. So 8x squared y is my GCF. They both have that in common.